Okay, guys, so let's start today's session. That's more on Module 8 Virtual Machine Resource Management. In this lesson, we are going to cover about resource control. Resource control primarily meaning here is how we manage the resources on virtual machine, physical host, and how do we do monitoring of that, okay? So we will understand how the CPU values being shared, how the memory resources being shared, and describe how virtual machine complete compete the resources if in case any obstacle or any resource crunch happen. Define CPU and memory reservation and limits. What are all are these terms? All right. So if we talk about the general term about the resources that is being assigned to a virtual machine, all right, so when we say normally whenever we are assigning any resources to virtual machine, it doesn't matter it is CPU or memory, so we we have assigned as a raw resource. Okay, we didn't guaranteed of anything or something, right? So take an example. These are my running ESXi hosts, and the top of this host a virtual machine. Number of virtual machines are running actually. So I'll take one example for considering any of the virtual machine. And like for this example, I have given 8 GB of RAM or probably 4 vCPU with clock speed 2.3 gigahertz. Okay, so this clock speed, again, this will come from the CPU clock speed we are getting. Okay, so like for an example, my CPU clock speed is 2.3 gigahertz overall. So then it means that per virtual core, I am getting 2.3 gigahertz of CPU. Okay. But now you will say, sir, how it's possible 2.3 will be assigned? Yeah, you are absolutely right. That's what we are going to understand by this module. Okay, how these values being shared actually. Okay. So per virtual core will get 2.3 because here per physical core we assume 2.3 gigahertz of CPU value is coming. All right. So when we allocate the resources to the virtual machine, it could be CPU or it could be your memory. All right. So when we say the reservation means is we are allocating and we are fixing that value to be always available for that virtual machine. All right. So let us suppose out of this cluster for this particular virtual machine, I have fixed 2 GB RAM and the allocated like for vCP or maybe the clock speed, uh, we could say like under 4 vCPU. All right. So if we'll say we have fixed 2 GB, it means that 2 GB will be always available for this. It means that if within cluster I was having 30 GB of RAM, then you could say 2 GB is completely reduced from that. All right, because that is being fixed to the virtual machine. Now, to provide the VMs, to provide the memory to rest of the VMs, the available bank is 28 GB. So reservation is something a fixed value that is being assigned to a virtual machine. A limit. When we say a limit specify an upper boundary of CPU, memory, or storage can be allocated to a virtual machine. So limit is the maximum cap. Okay, the VM cannot go beyond that capacity. And how much maximum limit we can set? Up to the available capacity. When we say up to the available capacity, it means that if in case we have assigned 8 GB of RAM, then max limit also have been defined here 8 GB. All right. So virtual machine in any case will not use more than 8 GB. Okay. And your minimum reservation is 2 GB. So it means that your memory utilization will be happen somewhere in between 2 GB to 8 GB. All right, clear? When we say a share value that specifies the relative priority or importance of VM's access to the given resources. Okay, so share value means is whatever I have in the bank means is under my cluster or maybe the host, the free resources. So does not matter how much memory or CPU we have assigned. Like for example, the assignation memory is 4 GB, 2 GB, 8 GB. All right. So somewhere those resources be given from the underlying physical memory. Correct? Right? So under this 8 GB or 2 GB or 4 GB, we can see the resources values have been differently assigned. Okay. But whenever it comes to give the actual memory under this 8 GB or maybe under this 2 GB or maybe this under this 4 GB, the hosts always try to give the equivalent share. Equivalent share means is within 2 GB, whatever it wants to use, ESXi will try to provide that. Within 8 GB, whatever memory has been given, ESXi will try to provide that out of 4G. So ESXi by default, normally, it will not do any partiality. Partiality means whatever in memory bank, equal share for each. Equal share means is equally value. He behaves equally for each and every virtual machine. It will not differentiate. But it doesn't mean that tomorrow if you require 4 GB, it will provide. No, not like that. Within provided value, the behavior of ESXi is always equal. But when questions raise, sir, what will happen if in case I feel memory crunch? How ESXi will decide to provide the same example for CPU as well. Okay. When I say memory, you can assume I am talking about CPU and storage resources as well. So in that case, what will happen? So do you guys invest in share anytime? Share market? So what do you understand by the share value? Share value means is always here in VMware environment, there is 3 share value: low, medium, high. The ratio between these share values are 1:2. If I'll compare from low, it is 4 times. Or I can say like that, 1, 2. The same example. Okay. This is the difference. So by default, for each of the VMs which are getting the resources from the host, share value is medium. Share value is medium. Let us suppose this medium share value is 1000. So this is just a share value. It does not mean that it is indicating any 1000 MB or 1000 GB of memory. A memory distribution or CPU distribution can be different value. But now questions come here. Sir, I have give equal share value to the virtual machine, not equal memory, equal share value. Equal share value means is whatever memory I have assigned, that should be given at that point of time from the memory bank. Suppose that this memory bank is 16 GB. All right. Now, let's assume a situation where I say by default for each there is no difference. ESXi will equally behave for each virtual machine, all right, while assigning the memory resources. But there could be a situation, my memory bank is almost full here, but now there is an emergency at the same time for this VM also that requires, like at the moment that require 4 GB RAM, and at the moment that requires 16 GB RAM up to max capacity or maybe any value. But what my ESXi host is feeling, a Mr. X and Y machine, whatever I have given already being utilized, all right, and already I want any partiality for each and everyone. I have given equal shares. Whatever assigned to you will be given to you at the moment. But whenever I have the crunch, I am unable to take the decision to whom I should give the priority. All right. So this priority, now you say, sir, for me, this VM is critical, more critical as compared to this VM. And if in case any memory crunch happen, or again I'm repeating the word again, if CPU crunch will happen, you always give the priority to this virtual machine, all right, to this virtual machine. Again I'm saying 1000 is not 1000, just a medium share value. Okay, it is just a value, it is not any, it is just a share value, it is not any your memory value. Okay, so how I can differentiate this thing? So what you can do is, you can define the share value for second VM high as compared to the normal value of machine 1 and machine 3. So come back to same situation. There is a memory crunch is happening, but at the moment this machine also require the memory, and this machine also requires same call happen. And the moment we have ESXi not have the sufficient memory to provide VM. So in this case, which VM have the higher share value of CPU and memory, the host will give the priority to that VM, because if it is case high, it means that I am assuming the share value is double as compared to the share value available normal for the virtual machine. So that point of time, priority will go to the second VM. Got it? You clear? Yes, no?
Yes. So if we increase the share value, priority will be for
Priority
that
will
VM.
be for those VMs. Correct.
And if it will be, means there is no any share value increase, so it will depend on the ESXi, right?
Yeah. So at the moment, if ESXi have a crunch, it will either it will divide the available share equally, or it will not assign to anyone. Got it? Let us suppose the moment situation come, both the VMs it require full 4 GB, it require full 16 GB. But at the moment, the free memory available is 2 GB. So what it will do? It will give 1 GB to each. Does not matter whether that is fulfilling its requirement or not. Okay? Get it? Yes, no?
Yes, yes.
See why you clear on it? Same thing will happen on CPU resources sharing, your storage resource sharing, same mechanism will use. Okay? So share value is primarily defined. Yes. Even.
No, sorry, here is like 8 GB and 16 GB and 4 GB. So
Mm-hmm.
whenever the crunches happen, so it look for the whichever it is high.
No.
High GB,
No. I just gave you an example. In case of crunch will happen, it will always prefer the VM which have high share value. I can take high share value to this VM also. Not this number. Again, I am saying, not go with this number.
How it takes the high share value, sir? Which how?
That we will define from the virtual machine level. Priority will be defined with normal, high, and low. There is 3 value I can define: low, medium or normal, and high. Priority does not mean to give a high value. I took just an example. I prefer to give higher value to this VM. All right.
No, sir. Now, in what way it takes like it's a high, it's a low, and medium?
There is a setting in virtual machine. That's a good question. There is a setting. Probably you will get a numeric number low as 500, normal as 1000, and high is 2000. But again, these are just share value. That's representing my share is half, my share is complete, my share is double. So it means, yeah, correct. So I cannot define all of three one time, any one time. As I said, 1000 is not any value, it is just a share value. Simple example, in one company you are investing some money. You have purchased only one share, I have purchased 2 shares, and Praveen have purchased 4 shares. So whose part will be more?
Okay.
Praveen's part, right? Correct? So 1000 is not any memory value or CPU value. These are just representing your share value. Either you are low or high. Got it?
Okay.
So priority will be given to the higher one. Does not matter what is the memory allocated. Normal will be normal, equally behave. But if in case somewhere you have defined low, let us suppose for an example, VM1 low, VM2 normal, VM3 high. So it means that whenever memory crunch situation will happen on the host, priority will be given to give the memory to VM3. Does not matter how much. Means according to allocated one, right? Second priority will given to second VM, and third priority will given to first VM on the basis of memory allocated. Got it? Same thing will happen in case of CPU resources and the storage share resources as well. As I said, for every VM, by default, share value is normal. Okay. And it's all depend upon me. If I feel some of the VM I feel is a memory hungry and the has crunch, so I should prefer to give the highest value. I feel in case of CPU, this particular VM where I have put this application, this consume more CPUs as compared to another. More CPU means more CPU speed, bandwidth, and all. All right. So that case, we can define the high CPU value for that VM. Some VMs are storage hungry. They generate lot of IOPS. Either size is small or long. So that point of time, we can increase the shared storage value, IOPS value, as high as compared to low. Got it? So that all priority we have defined. So
Can you explain about the storage?
storage may
Suppose that
share value we can increase. Okay. If a VM have IO hungry, means like a VM where I have assigned a storage virtual disk, but lot of data read and writes happen to particular VM. So we can give high share value for the storage IOPS, then priority will be double as compared to the normal share value. Okay. All right.
okay, it is related to the IOPS, na?
Yes, absolutely right. And whatever resource we have reserved like today, I am doing this calculation on the top of 32 GB RAM for an example. But if I have reserved something for particular VM, then this calculation will happen on the basis of available bank 30 GB. 2 GB will be always reduced. Now my share will go out of this reservation value. Means whatever sharing decision will happen, whatever memory distribution will happen, it will happen out now 32 GB because 2 GB I have already fixed to particular virtual machine. Got it? And my rest of the available bank is 30 GB now. So whatever VMs will get created here, the share value will be distributed from this 30 GB, not from 32 GB, because out of 32, 2 GB has been given already as an reserve part. Reserve means fixed. You leave that. ESXi don't do anything for the reserve capacity, because reserve means that is fixed and that is allocated to some of the virtual machine already. That is considered as allocated. Correct? So there is one example here being shown in this screen. If a host does not have sufficient memory that is being reserved for virtual machine at the moment, that VM will not power on in that stage. Because if that sufficient memory is not available in ESXi bank, like for example, for a VM I have reserved 8 GB RAM. So it means that that's mandatory. Does not matter how much it will use for the power on and off. That is mandatory to give him 8 GB immediately. But at the moment, if 8 GB free is not available, that VM will not power on. Okay. By default, there is no reservation for the virtual machine, but yeah, we can define a reserved value if in case it is required. Some of the cases we say an application is mandatory to be 8 GB to run or something like that. That case we can reserve the memory. Okay. So same way CPU reservation will happen. So CPU reservation counts in megahertz or gigahertz that you can assign. The default reservation value is 0. So we can define the guaranteed CPU value. Like for example, I define something just for an example. 10 megahertz is mandatory. So again, the same example, whatever available megahertz capacity I have available, then it will be reduced the reserved value, and whatever calculation will happen, it will happen on this 3290 value. Okay. Reservation is something I have given, reduce that is fixed for the VM. Right now, whatever calculation for sharing the resources you will do on the remaining available capacity. Got it? So in which case we should give the reservation? Reservation on only like for particular critical application, we say, boss, it require 10 GB of storage. Anyhow, it require 100 megahertz of CPU. All right, that's mandatory to be run this virtual machine or application. So that case, we will reserve the minimum guaranteed resources for that virtual machine. And again, I'm repeating the word, whatever the reservation we have done, that will be minus from your CPU and memory pool within cluster. Whatever the total value we have, that will be minus. And whatever share will be given from the bank, that will be from the remaining value out of reservation. Right? Clear? So where we can define the RAM limit, CPU and all, that's all available within the virtual machine setting. Okay. When we'll expand, then you can see the value, and you can see here a value normal. Okay. Here you will get low, normal, high, and then you will see this share value will be change. If in case normal it is 1000, it will be high. When you will enable high, it will be double of value. Or when it will do the low, it will be half value. Okay. So by default, share behaves equally for the VM. So these are the value have been defined for CPU. 2000 is considered high, 1000 considered normal, and 500 considered as share value. Again, I am saying these are not some value in megahertz or CPU, nothing. These are just to indicate this is low share, this is normal share, and this is high share. It means that half, 1, 2, or 1, 2, 4. You can take any ratio. All right. Okay. Same way for memory. 20 share per MB for configured memory. 10 shares milenge if we'll do the normal, and 5 share milenge per MB se five shares in normal. So it's a ratio again, 1:2:2. I mean, or we can say 1:2:4. It is 4 times. So high value is always 4 times with low value. Got it? Yes, no? So it is just an example, like number of share have been given equally to 4 virtual machine. Change the number of share. If I will change for virtual machine this, how many? 3000. It means that we have increased the value. All right. So priority will be given when it power on the another VM. The priority will be always given in case of resource currents to this virtual machine. For rest of the virtual machine, it will be divided equally, whatever the available capacity I have in memory pool or CPU pool. Okay. Then if in case this VM will go power of any VM, then definitely I will get some bump up in the capacity. Then that will be divided equally. It's moreover like in market, your company will increase, your share value will increase, right? Got it? Same way here. So for an example, earlier I have just an example, 10 GB of pool. So out of this 10 GB, this value normal, high, normal. But if this VM is get power off, it means that within this 10 GB pool, I got some buffer because one VM is power off. Then automatically share value will increase in the ratio to these rest of the 3 virtual machines. If for example, I say this is also power off, then share value will be equal, but definitely in ratio that will increase because for now only 2 VMs are running in the environment. So that my 10 GB will be strongly, this can be shared among these 2 virtual machines. Got it? Yes, no?
Sir, here one doubt.
Tell me.
You told us the power of when there is like two VM has been powered off. Now like we have like enough memory and enough CPU, sir.
Yeah, simple example, Siva. I have 100 rupees. Now you are 4 people and I am saying to these 100 rupees, I have to share equally in 4 people. How I will share? 25 rupees, 25, 25, 25, correct? Now I am saying this candidate is no more available. So now how many people you are? 3. So if I will divide this value by 3 now equally, how much it will go? So it increased, na? It increased on the ratio whatever share have been defined. So in this example, I am saying normal share. Another example, I say I have 100 rupees. I have the 4 people. For 4 people, I am saying 50 rupees to this one and just give out of 50. 17 approximately 17. All right, correct? If one people no more available, what will happen? This ratio will increase, half you will get out of remaining. So this 17 का half इधर add हो जाएगा और out of that half here and here add हो जाएगा. तो definitely ये value आपका चला जाएगा. It will be approximately 59 and it will be approximately 21. So same ratio में shares will increase. Correct? The same example it is explaining here. Got it? Yes, no? Got it, na? So whatever in the underline, that is the part, that is the responsibility of host. On the basis of share value have been defined, it will distribute. That's it. Or maybe another example, here another candidate will join tomorrow in this example, but you have 100. So how you will share it? Because you have normally share 20, 20, 20, 20, correct? Then definitely share value will decrease, correct? If I will add one more candidate, then it could be 17.5, 17.5, right? This is the same example out of my bank. If something will go away, then for rest of the candidate, definitely they will get an advantage of the share values more. If you will keep on adding the candidate, share value will decrease. Correct? That's what it is trying to tell you under this example. All right, so these are the values from where we can see the share value for your CPU and for memory. Where is low, it is 500, and where is normal 100, and where is high, it is the it is double, right? So it should say high here in 2000. All right. So how we can see assigning share value to memory, resources, and all these components. So let me just share my screen back, and I'll show you from where we can do that. Okay. All right. So you pick any of the VM from here. Like simply I'm taking one VM. Let me just refresh the page. Yeah, it is signed off. Let me just sign in back again. All right. So if I'll take some of the VMs from here, if I'll go to edit setting, if I will expand the CPU, what is the share value? Normal. Okay. So what are the different values here? Low, normal, high, custom. Custom means I can define any value. So if I'll make it high, it is double of normal. It is the double of normal. And if I'll make it low, it is half of the normal. Correct? Same way, by default, as I said, CPU share is normal for each resource. Same way, if I'll go to memory, also this is the normal value. So it is being divided from your available memory. But again, if I will do it as high, so what will happen? It will be double. It will double the share value. Correct? It means that whenever the similar kind of VM, or maybe the VMs have allocated different memory, have resource crunch, the priority will given to this virtual machine. Okay, the priority will given to this virtual machine. Same way for hard disk IOPS, you see here share value. Can you see that? By default normal. By default normal. So if I'll make it normal, it will go half. Sorry, low, it will go half. But if I'll increase it high, it will go double of normal value. And if I'll do some custom, so custom means is I can put a value on the basis of my design. Like I don't want to keep it high, I can make it 2.5 as well, because between normal and high ratio is 1:2. Okay, I can make it 2500 as well. So they have given an option of the custom value as well. All right. Okay, then let us see something on CPU memory reservation part also. So how much CPU you can reserve for this? The maximum CPU you can reserve less than the value have been assigned. So reservation is 0, then you can define in value megahertz. So if you will say, sir, how much megahertz I am getting on it? Simple, whatever host clock speed is available, CPU speed is available, under that you have, because here you have you have one socket, 2 core. It means that you will get double of that value. Okay, what it mean? Double of that. If I will cancel this VM and I will go and check the individual host. What is my clock speed? So clock speed does not mean the overall clock speed. Clock speed means is CPU clock speed per core you are getting that value. So if we are saying 2 gigahertz, and how many logical processor I have? 56. Okay. So it means that is this 2 gigahertz will multiply by 56. One core, one processor have 2 gigahertz speed. All right. So now if I will pick any of the VM, again I will go to this VM back, edit setting. So if I will expand the CPU value here, how much I can measure? So how much CPU you are expecting for this VM? 2 into 2 gigahertz, totally 4, because you are getting 2 virtual core. All right. 2 gigahertz means in 1 gigahertz there is 1000 megahertz. Okay. By default, no reservation, no limits have been defined. But if you will say, sir, I want the minimum reservation for this host is 1000 megahertz. All right. Then you can define the value of 1000 megahertz. So 1000 megahertz is the minimum guaranteed value you have defined. And what is the limit? Limits you can define to maximum capacity that is being assigned. You cannot go beyond this. By default, it is unlimited. But yeah, unlimited means is unlimited up to this value. So in this value, how much CPU you are getting? 4 gigahertz total. Okay, maximum is 4 gigahertz. But out of this, if you want to define some value, you would say 1500. So always limit will be more than reservation, because reservation is the minimum guaranteed value and limit is the maximum guaranteed value. Got it? So in this way, we can define reservation limits and also the CPU. Like I have defined minimum reservation 1000. So simply your calculation from the pool of CPU, total CPU pool in this cluster, this 1000 megahertz value minus, then it will do sharing on the basis of available CPU. Got it? Pramod Oshyar, are you in with me? Yes, no?
Yes, sir.
Yeah.
Yes, sir.
It's a bit tricky. All right. So be clear where in which use cases reservation is mandatory. Limit is not normally we don't define, but yes, in some of the cases we give the reservation value. Okay. So why it is saying me that? Because limit cannot be less than reservation, because reservation is the minimum guaranteed value. All right. So can I define this value to my, by default limitation reservation is 0 and this value is what? Unlimited. Got it? So can I play something around memory in this case? Yes. Again, my reservation is 0 by default and limit is maximum unlimited. But again, I am saying unlimited to what? Up to the max capacity have been assigned. If I want to define something, I can. So probably limit, best example here is in your production environment, you have make some UAT, dev and test environment. And for that dev and test environment, you have created few VMs, but unfortunately, those VMs are consuming a lot of memory, and those are disturbing to your another production virtual machine. Then you can define a limit here. Don't go beyond this limit. Okay. Any case, you will not go beyond this limit for your utilization. Assignation can be anything, but utilization will not go this. If I'll say these are all guest memory, reserve means is whatever I have assigned, that completely I am reserving. Okay, that is the minimum guaranteed value. But as I said earlier, if a VM will not get minimum guaranteed value from the underlying resource pool means the available resources on my host, your VM will not power on in that case. Okay. So if I will come to my disk part, so disk part is here the share value, okay? But in disk, can we define limit or something? Limit the IOPS, we can do that, okay? So normally we don't put any limit on the IOPS. Okay, reservation you cannot, because disk size is your limit, your reservation, okay? Because you have assigned the disk, that's already being assigned, okay? And you can define the IOPS number, how much IOPS it will get. So by default unlimited, on the basis of the disk you have assigned, the IOPS will be there. Same way for share value, okay? So when do we need to change these values to high or maybe low? In case of I have the very low priority VMs, just define the value low for that. In case you have normal general purpose workload, keep the value normal. But if in case you have some heavy transaction VMs, so that heavy transaction VM you have to identify. It is CPU heavy, it is memory heavy, it is storage IOPS heavy. So to optimize the performance of those VMs with respect to these factors, we just increase the share value, so that whenever any resource crunch situation happen, always priority will given to those VMs. Okay. All right. So how you will check all these values? Like from VM level, you can check. And like if you will click on cluster and you will go to summary, then you will check for all the VMs. So probably for this environment, for all the VMs, values is being set it as normal. Can we see here something? CPU, memory, this. So let me check to individual host. Just 1 second. I will try to capture those values because I am on different laptop to showing you this lab. Let me connect with my mouse here. Okay, so can you see here? These are the status. These are not the share value actually. Is it showing somewhere? No. Cluster level. Is it showing? No. So what you will do in that case? In that case, simply those parameters have been not selected to show you the share values so far. So for that, you have to just select few of the options. So if I'll export here, what it is showing here, you can see here reservations. You can check that. Alarms, protection, guest memory use in percentage also, but it should show share value as well, right? Okay, let me just click to individual host and name guest OS, reservation, alarms are fine. It should be here itself. Status. I'm trying to find out that tab only, okay? Where it has
उधर ये राइट क्लिक करना है, ये नेम वेम के पास कुछ ऑप्शन आता है कि कस्टमाइज का?
ये sometimes it is
नो ये ऊपर सर, यहाँ पे ये आ रहा है नेम स्टेट स्टेटस.
ये यहाँ से अपन लोग वैल्यूज लगा देते हैं ना, ये ना सेम in export, but just 1 second. It will show all these values here. Can we take memory size, reservation? CPUs. ये reservation तो आ गया, CPU is there, but still it is not showing the share value, correct? It is normal. Status में क्या है? CPU reservation, host, IP tools, encryption. Should be here only, man. Something we are missing, that's it. So in monitoring may, I'll go to VMs. Does it have some filters here? Same thing, huh? और status है ये host size, memory size, used space, provision. One second, huh? Let me just. Should be here only. We are missing something. That's it. All right. So it should be okay. Go to monitor and this is the resource allocation. Go to CPU and you check here. For CPU reservation in 0. Okay. Can you see it? CPU reservation is 0. Limit is unlimited. Type fixed. Share normal. All right. And these are the share value. And especially for this one, you can see an NS60A share value has been doubled. And also for this appliance, share value has been doubled. Okay. It means high. Okay. So if I'll go to memory, shares, you see fixed. When say fixed, the memory is being fixed for those VM. Shares are, you can see the difference, but yeah, you can see a bug here as well. Share value normal, ideally it should show high when we do the comparison. Okay, so normal value is here 8190, low value is this one 40960 is the low value. Okay, and 8190 is the normal value, but you can see the difference here. Okay, you can see here this value 2.5 and the upper share percentage is double 2.51, double it 5.02, and the value where you have 40960 it is 1.25. correct? It's a ratio 1:2:4. Got it? Clear on it? Why these values are coming 5? Because it's a percentage ratio. The machines which have low share value 1.25%, the machine which have normal 2.51, machine which have high 5.02. It means it is a ratio of 1:2:4, you could say, between low, normal and high. All right, clear? Yes, no?
Yes, sir.
Same way for storage, by default share value have been defined 1000. It means that whatever storage IOPS have been available, those are being equally shared on the basis of allocated disk. But yeah, if some case we will increase, then definitely you will get the increase. That's why this value is saving equally 2. Probably for any of the VM you will change it, the share value will be double. Okay, and I told you all of the 3 use cases where and how we should take care of CPU share value, CPU reservation limit, where and how we should take care of memory share value, memory limit, same way for storage IOPS. Okay, if my application is very much CPU intensive and took more CPU as compared to another VM, double the CPU share value. My virtual machine is memory heavy, cater more memory whenever execution of that application, double the memory share. Okay. Same way, if my VM is storage IOPS hungry, double the values. Okay, increase the values. All right, and limits, and when we say the reservation, we should only define in that case where we say this guaranteed value should be available to power on, to turn on that VM. Then we have defined the reservation for those particular virtual machines. And whatever resource have been assigned to the reservation, like for an example, we have reserved the 10 GB memory to 2 VMs out of 40 GB band. Then rest of the shares will be equally divided from 30 GB, not from totally 40 GB, because 10 GB will be minus, because that is being reserved, fixed. Got it? Now question came, sir, you are telling me again and again the high value for 1 VM. What will happen if in case high value for 2 VMs or maybe more than that? That is also a possible use case. Then what will happen? Priority will given to those 2 or 3 VMs where higher value will define, and the remaining share will be equally divided on those 3 VMs, because those 3 VMs have the high value. Got it? Simple use case. What I'm trying to say you, if, let me share my screen back. There is not only one VM. There could be the number of VMs can be available where CPU share value is high. So what I'll do in that situation? In that situation, my priority will go to those VMs and it will be equally shared. Okay, I have an empty slide here. In one example, you can understand for CPU, memory and storage for any, all right? So if in case I say this is my host, and again there is 1, 2, 3, 4 VMs I have defined. For example, I have defined for memory low, normal, high, high. It means that whatever underlying memory bank will available, that will divide 1:2, 4, 4 means that 4 times of this. Okay, then there would be total share would be how many? 11, correct? But out of 11 shares, as per this example, the priority of these two virtual machines. So whenever any memory crunch will happen, the priority will given equally to these two virtual machines. Second priority will be given to this, and the last priority will given to this. But only, again I'm repeating again, it will only happen, share value comes in picture whenever any resource crunch happen. If everything is normal, then that's not a problem at all. Everyone is getting everything, whatever have been assigned. All right. So this could be, there could be number of VMs where we can define the share values for high for multiple VMs as well, for the multiple kind of resources. All right. Good. Yes, no. Simple AR. In again, I'll take an example of share market. There could be multiple shareholders in the market who can invest more money as compared to you. Okay. So again, whatever share being defined, he will get the same value in revert. Same example here. Whatever the share value being defined, they will get the same value in revert. Okay. All right. So if no question, let me finish a small quick module. We good? Yes, no? Pramod, Praveen, Siva, are we good?
Sir, one question, sir.
Yes, yes, please.
You can
Questions are always welcomed. Yeah.
Sir, you told that high, two VMs like high and others like normal and one is low. So in real time, how that works? So sometimes they ask for to increase the memory for the low VM because of the memory crunch.
See,
That time, is it possible, sir?
no. Actually, you are mixing two use cases here, Siva. Allocating memory is a different thing, and share distribution is a different thing.
Okay.
Sharing priority and lower will give the priority to your VM whenever any crunch happen. Crunch means is simple example. I have in bank, again I'm giving you one example. Take this for all, whether CPU or memory. Like I have 16 GB RAM here to be available to allocate to my VM. So for one VM, I have allocated 4 GB. To another VM, I have allocated 8 GB. To another VM, again I have allocated 8 GB. All right. And the time being, I feel there is no problem at all. I am giving VMs is using 8 GB not every time, up, down, up, down, up, down, up, down, up, down. Now I came to a situation where where at the moment this VM were using 6 GB and this VM immediately go to high peak utilization 8 GB and this VM is also go immediately to high utilization of 4 GB. So now how much you need? 6 plus 8 plus 4. How much you want now? 18?
18.
Correct? But now in the case this host comes on a stage, he is not able to allocate because of this demanding more memory. This is also demanding more memory. Okay. All right. Up to is full. So in this case, how my ESXi will take decision from this memory pool to whom I should give the priority. Then your share value comes in picture. It will see, boss, your share value is high, your share value is normal, and your share value is again normal. So for this VM, there is no problem. It is using less than. It is okay. But there is a dispute between this VM and this VM. To whom it should give the memory first. So it will give the memory first. Like for example, right away it have 3 GB free for an example. And immediately it need to give to this and to this. How it will distribute? It will distribute this memory 2 GB into 1 GB. Because the share value have been high for this VM as compared to for this VM which have the share value normal. Get it? Yeah. So from the available
it is like automatic, sir. Automatically.
Yeah. It's an automatic process. That's why this share value comes in picture. I told you na, by default for each resource share value is normal. Whenever any crunch happen and a VM are desired to hungry for any resource, CPU, memory or storage IOPS, it will equally divide. If there were a situation, the share value was normal. So what it will do? It will give that 1.5 and 1.5 to 2. But when I say my 4 GB have the more priority as compared to this VM, this application should get the required memory whenever it needs. So we have given the priority by defining the share value.
Sir, when it's automatic, as an admin, what we do here, sir?
As an admin, I give you an example. My priority will be give if this is a memory hungry VM, my best practice to say give the share value high as compared to normal.
Okay. We define this thing, sir. Whichever is this thing, we define. As admin, we define.
Yes, true. Then you need to coordinate your application owner. Boss, I am giving you 4 GB, but out of 4 GB, what is average? Then he will say, boss, I can touch anytime 4 GB. And you feel your cluster is going fill every day, then give the higher value to that application so that can get the desired desired memory. Okay.
Like
Okay.
one time configuration.
Now I come to your question. When you say, sir, we increase the memory, you are right. You take this example again. If I will increase the memory to this virtual machine, but my pool is about to fill. What you will do that? What is the advantage of that 8 GB? Nothing.
Yes.
Correct? Then
Yes.
the share value comes in picture. If you want the desired memory to up to fulfill maximum, your priority will be higher as compared to the VM which have the normal share value. Got it?
Got it. Got it.
Yeah. Then lesson 3 is about resource monitoring tools. When we say resource monitoring tools, simply the tools which help us to identify the utilization for the for my host, for memory and all. Okay. So normally we keep a baseline for any kind of resource utilization, primarily from compute, CPU, and memory. So we design our cluster in a way CPU utilization should be vary somewhere this. Memory utilization can be vary somewhere this. Okay, same way for your network. So these are some thumb rule values. Okay. So if I will say my memory utilization is not for the cluster, it is somewhere 30% or 35 or 40%, then we can simply say this is underutilized. We are wasting our resources. Correct? Or in the current situation, maybe customer is planning to move some VMs in future, that is okay. But yes, if my utilization is less than 30%, it means that my cluster has sufficient resource for now. Same example for CPU. But if my overall utilization, overall means clusters, host utilization, I see a average utilization between 70 to 80%, then it's a warning for you. Warning means is either you should not provision more VMs or you should add new hosts in your existing cluster. Got it? Because this 70 to 80% is always a warning. Maybe suddenly some of the applications are heavy CPU consumption or heavy memory consumption. It will go to 85% or maybe 90%. Then lot of alert and lot of alarm will get created. Got it? So how do we do the monitoring of these resources? So inside the guest operating system, like we run perform DLL or Windows Task Manager. In Linux, we have top command. Outside means in host, in my vSphere environment, we see the vCenter performance chart. We realize operation is the best monitoring tool to give insights, check the logs. ESX top, RESX top are the command to check the current utilization of CPU and memory. Okay, but normally people don't prefer to capture the logs every time or to run the ESX stop command every time. So that's why we realize Operation Manager as an additional tool to show you the live monitoring for your cluster level, host level, VM level. Let's do the live monitoring of the resources. Okay. So if you are good in Windows, probably you have seen into the performance monitoring tool within Windows inbuilt. You can check overall the CPU utilization. Primary, it show you 4 factors: CPU, memory, disk, and your network. All right. So these are the primary 4 factors that's normally being considered. And if in case you want from OS side, you can check. From the OS side, you can say, boss, my CPU is hitting 70%, 80%, 90%. Allocate me something more. So how you will increase the CPU in case of memory? So simply you will increase some, like for an example, earlier you were doing 4, and out of 4, how much speed you are getting? Like from each core, you are getting 2.3. So earlier it was 4 into 2.3. Now you say I need more clock speed. So what you will do that? Just increase 6, then it value goes 6 into 2.3. Then automatically you'll get the more clock speed. Same way for memory. Earlier it was at 8 GB, but it's touching 70-80% every time from the VM. Tell them to increase the memory like 14 GB. Same way for your disk size. Maybe you can take disk utilization is going 80-85% now. What I should do? So expand your disk from the outside and make it up to 25 to 40% increment and do it. All right, network normally we don't get any problem. So these are some performance parameters you can monitor from inside the VMs. And these are some ESX top command. You can run this utility ESX top and you can verify for each of the VM what is being happening, what is my ideal situation, what is the wait time, what is the CPU ready time. Okay, for the virtual machine level, it will give you the report. But again, normally people don't repeat too much. They normally use the VROPs in current environment and just set the parameters once and keep on tracking the graphs on the ES on your VROPs itself. Right? So monitoring inventory object. So these are my performance chart, which I can collect from the vCenter console itself. I can select the parameters and I can check what all parameters we need, and we can, some of the chart we can see live and some of the chart we can export as well, and we can make our custom chart also. So like the way these are all chart metrics, I can collect these like particular parameter, this one, this one, this one. If I want, I can collect. So by default, it will giving you the real time. Real time means what is happening in current situation, and you can define a time interval. For the time interval, you want a chart. Like for example, you say I want for last week, what's happening for these parameters. For last month, you can do that. So these are the time values. In real time, it will give you, it will update the parameters. Like for an example, we are checking memory updates. So it will give a dot every 20 seconds. If you will say past 1 day, so you will get the updates after each 5 minutes interval. If you will say past complete week, then after you will get one update point after 30 minutes. Then per month, you will get an update point after each 2 hours. What will happen on that point? And if you'll say complete past year, it will give you day-wise inventory. So it means that first day average was this, second day average was this, third day average was this, fourth day average was this, fifth day, like that way. So it's all depend whenever we want to capture the chart, it will give you the like you say past day, it will give you each inventory after 5 minutes, 30 minutes for past week, past month 2, and past year for 1 hour. So we can export any chart from the vCenter as well. So that's an example where we can export the chart from the different values. Okay. If we want to see live, we can also see some of the live parameters, like in the real-time monitoring is happen. Okay. When we say real time, it is showing you like all these, whatever the factors you have selected here, it is showing you different color. Okay. So I don't think so it would be easy to track the number of colors, number of lines at the moment. But yeah, so some major parameters like CPU average utilization, memory utilization. So all the chart you can export on the for entire cluster, for individual host, for data store, for network, for individual virtual machine as well. So it's all depend whatever you want to check, what you want to analyze, and what you want to export. All right. So these all are the chart, and then you can export it in a form of JPG or CSV, SVG, PNG file. So these are the different format. We can, like for an example here, I have given the CPU utilization for last month. Chart option is CPU uses in percentage. I want in CSV. So this will give you me, this is my custom chart. Okay. This give me overall CPU utilization, what happens overall in last 1 month. Okay. So you can go ahead, check the specific option, and you can export the chart for a specific value. All right. So these are some examples you can take as a parameter. Like for NIC perspective, CPU perspective, vCPU 0, vCPU 1, these are your vCPU cores normally. All right. So rate means what is CPU being used, CPU ready time, delta, absolute is active memory. So these are some, again, some statistic types and their examples, what we are getting from selecting particular parameter. Okay. About roll up, again, it's the same example, average value, some latest, minimum, maximum. These are your chart characteristics value. Then you can select. Yeah. So resource uses for, again, these are the example like from vCenter server. You can use CPU chart or from the virtual machine itself, or either the same chart you will get from the VM setting, particular virtual machine, and take the parameters, or you can check from inside the operating system. All right. or CPU constraint VM, then you will be able to find like the utilization have been happened. So probably you could see the 100%. All right. So it means that is that Flux VM you could see here touching every time more. That means this is the CPU constraint VM in my case. Like multiple VM could have the CPU constraint. Again, we have to select the chart, whatever we wanna export for the VM level. But be frank, out of 10 issue, 8 or 9 issues are moreover around your virtual machine memory itself, not the CPU, because CPU are pretty much enhanced being done. But yeah, whenever we see any crunch issue, that was around the memory constraint. Okay. So we can monitor it, but again, I am saying you, these all monitoring factors, people don't go ahead and do the chart collection and all each and every time. That's good to go with the VROPs. That's so use the real-time graphs every time, a one-time activity, and you can go ahead and you can go and check that. Same way for disk, you can do disk latency, network constraint VM. So these all are the parameters that we can define. So in some lab, create CPU workload, check the performance chart, remove CPU affinity. So what we can do, we can increase the CPU cycle for any of the VM, and under my monitoring, I can check that. And later on, I can increase the CPU value and again check that time you will get it's fine. Okay. So for this, I will just share you one video for this lab actually, because create CPU workload is not possible for me to show you how it will be done. All right, because there is some scripts being defined to increase the CPU. Just an example, in real environment, you will find some real things. Memory utilization go high, CPU utilization go high. Okay, then you can do it. Okay. So here it show you na CPU, this change the share value to normal because earlier CPU value was set been low. A script being run here, a CPU demand high, then they will change it from to normal. Earlier it was low, then they change it normal, or maybe normal to high. The same example like I show you. All right. Yes, that's it. We'll not cover more than this because we have already passed 20-25 minutes more than. And tomorrow we'll see the alarms, how we'll see the how we can create alarm, what is the definition of alarms. All right. And we'll be finishing this module. If you guys okay right away, I can do it. Or all depend upon you.
We can start tomorrow.
Yeah, cool. That's fine. And around this lab, I'll send you a recorded video from where I have run some scripts and all. I'll showcase you that. All right. Thank you guys. Have a good day and let's connect tomorrow at the same time. 9:30 will be okay tomorrow as well.